Hey guys, welcome to question FM 284 of the Further Maths 4 to 5 study guide. This question reads, a council requires 8 houses to be connected by landlines. The houses P, Q, R, S, T, U, and V and W are shown as vertices on the graph below, and then we're given a graph that looks like this one here. The edges of the graph represent the landlines that could connect the houses. The numbers on the edges show the length in meters of landline required to connect the houses. Question A asks us, what is the length of landline required to connect houses W and V? Looking here, we can see vertices W and V, or houses W and V here. And this edge, which shows the potential length of landline needed to connect the two, says 170, which we have been told is in meters. So because the question asks what is the length of landline required to connect houses W and V, we must say 170 meters. The meters here is important because we haven't been told to use a unit of distance. So we have to let them know that we know what that unit of distance is by putting in M or meters, or just not having 170 on its own is fine. Question B then says, what is the least amount of landline required to connect houses S and W? So it'd be good for you to sort of go through and have a look at a potential couple of ways of getting from S to W. So you could go from S to U, then U to W, S to T, and then T to W, or try a few different ways. But eventually you will come to this same path, which is S to T and then T to W. So we're simply adding 180 and 190 together, which if we put that into a calculator, we should get an answer of 370 meters. Once again, important to include the meter distance in there because we've been asked, or unit in there, because we've been asked what is the least amount of landline required to connect houses S and W. Once again, we haven't had a unit specified for us, so we must include it in our answer. We're then given a little bit more information, which says, a construction worker wants to lay the landline down as one continuous line that will create a circuit using every edge from the graph above, being this graph here. Question C says, to ensure that the landline is laid down on each edge only once, which vertices is the construction worker able to start from? Now, the type of layout that this construction worker is talking about, he wants one continuous line that will create a circuit using every edge. So it needs to create a circuit and use every edge, which means that we're looking at an Eulerian circuit. Now we should know by now that an Eulerian circuit exists in any graph or in any network where all of the vertices are even. You can see here that every vertex in this graph is of even degree, meaning that we can, and with an Eulerian circuit, we can start and finish at any vertex as long as they're all even, which of course they have to be in order for an Eulerian circuit to exist. So the answer to this question is any vertex, because we're making a circuit, that makes sense that we could start and finish at any of the vertices within our circuit. Question D starts out with, another construction worker says that the landlines will work as long as each line is connected to at least one other line. The process that will use the least amount of landline follows a minimum spanning tree. Question I wants us to draw the minimum spanning tree on the plan below, and then we're given a layout. I've got a couple of vertices plotted here, and just going through the process of how to find the minimum spanning tree for a network or for a graph. So let's say that we started at vertex Q. So following Prim's algorithm, we're going to pick a vertex to start at. We're going to pick Q. Our best option to start this network coming out of Q starts at this 150 here. So Q to S contains an edge with a weight of 150, and that is our first best option. From here, we've got a few options. We could either go down this 280, 160, this 180 here, 190, or 230. Of course, our next best option is this 160. So following this algorithm of finding the next best edge to add to our little tree, you should end up with something that looks like this. And this should be the minimum spanning tree that you see pop out from that process. So that's part DI. let's talk about II. So we give a little bit of information here that says one of the houses, W, is demolished and no longer needs to be connected by landline. Part II says how much landline would be saved if house W is removed from the minimum spanning tree network. Now you could go through the whole process of redoing this minimum spanning tree. However, if we are to knock out house W from our little network here, the shortest way to connect it all back up is by adding in this edge here with a weight of 280. Now this question actually asks us how much landline are we saving by doing this. So finding the total of your previous, or the total weight of your previous minimum spanning tree, you should get, and I'll change this to total of old maybe. So total old, you should get an answer of 1,350 if you add all those old weights together. Adding all the weights from this new graph that we've created, you should get a total weight of 1,270. And of course, when we take 1,350 and minus our 1,270, we're going to get an answer of 80 meters. So we can say something like 80 meters is saved. Excellent. And that answers part II, the last part of this question. So if you guys have any questions for us about any of these, please leave them in the comments below. Otherwise, I'll see you in the next video.